In this video, we'll talk about demand patterns. Water consumption changes with the seasons, the day of the week, and the hours of the day. Fluctuations are greater in small rather than large communities. This fluctuation of demand throughout the day is called the demand pattern. When we look at the data, we see the demand pattern changes with location, season, weather, if there are any special events, and so on. Diurnal variation is very strong and impacts heavily on the design. The figure here shows water consumption by different households in a small area of Melbourne. We can see there is a big difference between the peak water usage and the low water usage in all different households, 1 to 2 person household, 3 to 3 person household, and 4 to 5 person households. If we are using constant water throughout the day, then size of the pipes required would be much smaller. But that is not the case. From the figure, we can see the peak demand lasts only for a few hours, right? So if you see here, the red one is only about 7 to 8, and for the blue and green also only for a couple of hours. So that means we are underutilizing the system, and we need to design the system that can provide water during the peak hours. This figure here shows the total water supply from a reservoir in a particular township. We can see more demand, so these are during the summer months, right? And this is the winter months. So we can see more demand during the summer months than winter months. Why? When it is warmer, we tend to do more of the activities that use water, such as watering the garden, filling our pools, having excess showers, and so on. Let's assume this township includes 600 properties, right? So um, we have the daily water usage, and the township has 600 residential properties, and there are no other industries and other properties. So we can just assume the residential properties only. Now look, if you look at the figure here, it shows the average is 454 meter cube per day. So maximum is 800, minimum goes to less than 300, but in an average 554 meter cube per day. And if you want to convert that to per property, then the average is 554 meter cube per day divided by 600 households. That means 0.756 meter cube per property per day is the water usage. And then you can also convert in terms of per person or per capita. So if you know what is the number of population per property, maybe 2 or 2.5, 3, or that you can get from the statistical bureau of the particular country or local council, and then you can use that to get what is the per person water usage. Now, when we design our system, we can't only consider average day demand. So if we consider that 554 meter cube per day and design our system, what will happen during this peak day consumption? We wouldn't be able to service um, the community with the required amount of water, right? So we need to think about the peak daily consumption, which is 802 meter cube per day. So for the daily maximum daily consumption, the demand per property is 1.336 or 1336 liter per property per day. And then from here we can see there is a difference. peak daily demand divided by the average daily demand is 1.77. Okay, so that's the peak daily demand factor is 1.77. So if you look at the council guidelines, they will provide you the average daily demand and they will provide you the peaking factor. Okay, so they wouldn't give you the peak, what is the peak daily consumption, what is the minimum, but they will provide you the average daily demand and then different factors to calculate the peak daily demand, to calculate the peak hour demand. You just use those factors. So for this particular example, the factor is 1.77. Now, so far we have considered the total demand per day, but the point is water demand to each property is not constant over the course of the day. So that's another fluctuation. Yes, there is a seasonal fluctuation and we have considered the total demand per day, the maximum total demand per day, but there is even in that maximum daily demand, there is a fluctuation within that day. And that also needs to be considered in our design. And that demand pattern, that daily demand pattern varies depending on the property category. If it is a residential, then we have seen as in the first slide, the demand pattern. For commercial, it would be different. Maybe commercial area, you just use the water during the day and the nighttime nearly zero or very less amount of water. For industries, depending on type of industry, they may use constant water throughout 24 hours. So it depends, right? So we need to use the proper demand pattern of different property categories. Now, this is the temporal variation in the water demand patterns for residential and commercial. Again, this is a typical demand pattern only. So this is for that particular, maybe for one particular area, and this is for one particular commercial or industry. But again, it would be different. And if you look at here, there will be, in this example, the demand factor is around 0.25 in the morning, and then slowly starts to increase as the people starts to wake up and then starts doing their daily activities, and then it peaks around 8, goes down, and then in the evening it goes up again. Again, this is a very typical, and you should not be using this pattern for your design. So if you are designing in Queensland, if you are designing in even within Queensland, Bundaberg, Rockhampton, Mackay, they would have different demand patterns, and you need to use that particular demand pattern. This is just to show how to calculate the discharge, because um, the demands are given in terms of liter per second. So from the water supply system, we measure average daily water usage is 454 meter cube per day. Now you convert that into per property once you know the number of properties, or per person if you know the number of person living in that area. Here there are 600 households, 600 properties, so 554 divided by 600 gives you amount in meter cube per day for property, and then you can convert that in terms of liter per second. Yeah, and normally in the guidelines the values are given in terms of liter per second. Okay, so it's just how to calculate from meter cube per second to liter. So this is normal. Now from this information we can see average demand pattern per customer is 756 liter per property per day. So we have calculated that. Peak daily demand per customer is 1336 liter per day. Peak day demand factor is 1.77, and peak hourly demand factor we haven't calculated, but if we have that information, peak hourly demand factor is 2.2. So if you look at these CMDG guidelines, you will have all these information. Okay, so if you have the information of water flow in the area, you should be using that to derive your average daily demand, peak daily demand, the factors and all those information. But if you don't have any that kind of information, then you need to look at the guidelines and look at those values. Okay, so even if you have those information, you need to check with the guidelines if that is too different, and if the council allows you to use the information that you get from your trend.